Welcome to Mr. Math Academy. Grow your math brain.
Hello friends, welcome back to Mr. Math Academy. So today in this video we discuss the very important topic here, that is the derivation of a length of the belt here for a open belt drive condition. Okay, now this is what actually the belt arrangement here for a open belt drive here. Now we are just seeing that, so this is our larger pulley here. So it's a member where it can transmit the power. Now this is our larger pulley, and you can just see this is the smaller pulley on which we will be having the belt is mounted here. Now we can just see there are some different some locations are there. So where we can just see there will be a belt which is in contact with some pulleys like the larger pulley and the smaller pulley, and in some points here the belt is not in contact with the pulleys here. Now we just go through here. I just take the point A and B, that is from point A to B the belt is not in contact with the pulley here. Again similarly from B to C the belt is contact with the smaller pulley, so through when it is transmitting the power. Okay, again we just see from C to D, again the belt is not in contact with any of the pulleys. Now from D to again it will be having a contact with the larger pulley. So means what, I need to find out what is the total length of this belt for a open belt drive arrangement here when some particular dimensions has been given. Like suppose if I have given the radius of a larger pulley is given and radius of a smaller pulley is given, and he has given that, so there will be a center distance between the two pulleys as C. In such conditions I need to find out, so what will be the total length of this case here. Now so here we just see here, if I take this is a 180 degree, but if I take this is the angle alpha here, from here to here if I take the angle alpha, since it says like a symmetry here, so this angle will also become an alpha here. Now from A to D, so this is the belt is in contact with the larger pulley, and which makes an angle of, it's a pi plus 2 alpha. Pi means it's a 180 degree, and we can just take this is alpha as well as this alpha. Now you can just see from B to C the belt which is in contact with the smaller pulley here, which makes an angle of pi minus 2 alpha, because since it's a 180 degree. Now if I take this is the angle alpha here, since it's a symmetry here, this will also become angle alpha. Okay, but the B to C is from only this angle we have to take, so then it becomes 180 minus 2 alpha, that is pi minus 2 alpha. Okay, these things I need to find out here. So from this I have taken that, so now this is the larger pulley and that is a smaller pulley here. For that I have taken R1 is the radius of the larger pulley, R2 is for the smaller pulley, and again we have taken that, so the center distance between these two pulleys as C here. Now I need to find out what is the total length of this belt here, so which means I have taken that, so L0 is equal to L1 plus L2 plus L3. Now L1 is nothing but, I need to find out the L1 is nothing but the belt which is in contact with the larger pulley, that is nothing but L1 indicates it's a length of the belt which is in contact with the larger pulley, that is I need to find out this length of a belt here, so that gives the value of L1. Now similarly if I find out that is from B to C, which gives that L2 value, it's nothing but it's a length of the belt which is in contact with the smaller pulley. So that is our L2 value here, this one. Now L3 is nothing but it's actually the length of belt which is not in contact with either of the pulleys. For example, you just see here, so that is the length of this AB plus length of CD. I can just take here L3 is nothing but it's a length of AB plus CD. So this is our L3 value. Now we just find out what is L1, what is L2, what is L3 in detail. Now after that if I just add with this all these three, I can get what is the exact equation for the open belt drive condition, that is the length of the open belt drive here. Now we will find what is L1 and L2. It's a very simple thing here. So I need to find out the length of this A to, and again that is A to D, that is for the L1, and L2 is nothing but B to C. Now how to find out this? The angle we know and we know the radius here. So since the A and D, so that is A to D, it indicates it's a length of arc here. For example, if I take this is the length here Now if I take this is a length some s, so this arc will be subtended by an angle theta here, which is having a radius of r, this radius of r from the center O. Then the length of the arc will be given by s is equal to r theta. That is nothing but the radius into angle subtended by that particular arc here. Now by using this, I will try to find out what is the length of this arc here. I will just apply for this length of the weld, that is A to D as well as the B to C. Now the L1 becomes, so R1 is nothing but, so I have to take the radius R1 here, that is for the larger. Now theta is nothing but I have to take the pi plus 2 alpha. So I just take here pi plus 2 alpha into R1. So this is our the L1 value, okay, that is the equation. Now similarly L2 is nothing but angle into radius, so that is angle is pi minus 2 alpha. So I just take pi minus 2 alpha into R2. So this is our L1 and L2, it's very simple. Now the thing is, I have to find out the L3. So to find this L3, I have to go for some construction part here. Without that, difficult to find out this. Okay. Now what is that construction part means? For example, directly I cannot find out what is the length of AB as well as CD. Now to find this, I will go for the small construction here, that is I have taken the O1 as a center for the larger pulley, O2 as a center for the smaller pulley. Now O2 as a center, okay, with reference to this O2, draw a parallel line where it meets P, and we have to draw a parallel line with respect to this AB. Consider O2 as a center, draw a parallel line to AB where it meets at P. Now after that, by the geometry, I can get this angle will also be angle alpha. So how means, for example, if this angle is 90 degree, that is from here to here. Now if I take this is alpha, the remaining this angle becomes 90 minus alpha. Now when we draw a parallel line here, we should get this angle exactly, it's a 90 degree, that is a right angle triangle will get. So this is 90, so this angle becomes 90 minus alpha, and obviously we will get this angle as alpha here, because the sum of all the angles of a triangle is 180 degree. If you use that, so easily I can get that this angle is also alpha here. Now from this right angle triangle, what I have got, when I draw a construction, that is O2 as a center, when I draw the parallel line for A and B, that is A to B, where it meets at P, it gives some angle, that is a O1 O2 P. It's a right angle triangle here. Now our intention is, I need to find out what is the length of AB and CD. So to find this, if I find out the length of this PO2, it gives, it's a same as the length of AB. So if I take this CD is also the same length here. So if I find out the length of this PO2, it's nothing but the L3 is a twice of this PO2, because AB is equal to CD is equal to PO2. So AB plus CD is nothing but it's a L3 is equal to 2 times PO2. Therefore I have to find out what is the L3 here. Now directly I will take, so with this right angle triangle O1 O2 P here. From this right angle triangle, I will try to apply the Pythagoras theorem. So for a right angle triangle O1 O2 P, by Pythagoras theorem, I will apply the Pythagoras theorem here. So if I apply the Pythagoras theorem, obviously we know that this is angle alpha, means this side becomes your angle, that is the opposite side here. So this length, that's nothing but your adjacent side. Obviously the O1 O2 becomes your hypotenuse here. Now from this, if I apply the Pythagoras theorem, obviously we are getting that O1 O2 square is equal to O1 P square plus O2 P square. So this is our Pythagoras theorem, but the thing is what, I need to find out what is O2 P here. So if I take this term to the left hand side, I can get that O2 P is equal to O1 O2 square minus O1 P square. Now I just take here, since it's a O2P square, I have taken here, I just take the square root here. Now what happens again, O1 O2 is nothing but it's a center distance from here to here, that is from two pulleys here. O1 O2 indicates it's a C. I just take here C square minus. Now so O1P is there. So O1P is nothing but from here to here I have to find out, that is this length is nothing but O1P. But the thing is what, since the O2B it's nothing but our R2 value, that is the R2 radius of the smaller pulley is same as your AP here. The O2B is nothing but AP here, which gives R2, but I need to find out what is this O1P here. We know that O1A is nothing but the entire thing, it's a R1. Out of this R1, if I subtract this, I'll get this as R1 minus R2. So now in place of this O1P, I'll just take R1 minus R2 and this is square here. Okay, now this is what we are getting here. Again for this, I just go for the somewhat the simplification here. Now for this O2P, so within this square root here, I just take the C square common here. If I take the C square common, I have to divide here by C square also. So this becomes R1 minus R2 whole square by C square. So this is what I have taken the C square common. Now after that again, if I take this C square and this C, that is a square root, it becomes a one C will be left here. The remaining thing is, so this C square and this C square get cancelled, so will remain 1 here, and again the remaining part is R1 minus R2 by C whole square. So this one what we are getting here. Now again the thing is what, this square root is there, I'll just take in terms of power here. So I'll get, so O2P is equal to this C into, it's a 1 minus R1 minus R2 by C whole square to the power half. So this is what we are getting after simplification. Now the very important thing is, so whatever the thing it's there here within the bracket, so I need to expand this term by using the binomial expansion, and after that, after expanding by using the binomial expansion, I have to consider the only first two terms, because after two terms you will be having somewhat the higher degree terms, we'll just neglect that part here. So that's why after expanding this by using the binomial expansion, so expand, on expanding the term 1 minus R1 minus R2 by C whole square to the power half by using binomial theorem. So we get that, okay, so we are getting, so this is our O2P directly. So now this C I'll write as it is. Now only for this term I am applying a binomial theorem, so I'll get, this is 1 as it is I am getting, so minus, so whatever the power it is there, for easy to understand, you just take this power half in front of this term and you can just write the second term as it is here. So this is half R1 minus R2 by C whole square. So this what the expansion of this term by using the binomial expansion. Only thing is what, we just take this half, that is the power half in front of this term here. That's the simple thing, just to remember. Now this is our O2P. Now we know that L3 is nothing but it's a AB plus CD. So AB is nothing but O2P. Now AB is also is equal to CD, so this is also O2P itself. So I can get that L3 is nothing but 2 times O2P here. Now L3 becomes 2 times this O2P here, that is C into 1 minus half R1 minus R2 square you can take by C square also you can take. So this is our L3. Now we just remove this bracket here, it becomes 2C minus 2 to get cancelled, 1C get cancelled. The remaining term is R1 minus R2 whole square by C. So this is our L3 here. You can just see this is the term what we are getting the L3 here. Finally the L0 becomes L1. We know that L1 plus L2 plus L3 here. So L1 is, it's a pi plus 2 alpha into R1. So L2 is nothing but it's a pi minus 2 alpha into R2 plus L3 is nothing but the term what we are getting here. I'll just take here, it's a 2C minus R1 minus R2 whole square by C. This is the length of open belt right here, but still we will try to simplify again this one here. So I'll just remove this bracket here. So I'll get L0 is equal to, just remove the bracket here, pi R1 plus 2 alpha R1 plus, so this pi R2 minus 2 alpha R2. So this term will write as it is here, 2C minus R1 minus R2 whole square by C. So this is the length what we are getting here. Again the simple thing is what I need to take out of this two term. I just take the 2 alpha common here. So L0 becomes, if I take the 2 that is a 2 alpha common. Now from this I will take the pi common. I will get pi plus R1 plus R2 here. Second thing is 2 alpha, I will take the common, this all becomes R1 minus R2. The remaining terms are, this is 2C is there. Again one more term, the last term is minus R1 minus R2 whole square by C. Okay. Now this is the term what we are getting here. Now again the thing is what this angle alpha is there, I have to simplify that part here. So we know that, so this is the thing what we are getting here. So somewhere here, so this is P here, this is O1 and this is O2, this is angle alpha here from that sketch here. Now since it's a right angle triangle, now from this right angle triangle I'll apply the sine function to find out what is the alpha here. So if I apply sine alpha, it's nothing but it's a opposite side, this is the adjacent and this is our hypotenuse. So sine becomes, that is O1P by O1O2. Now again we know that O1P is nothing but our R1 minus R2, because this is R1, out of this I have subtracted, this is the R2 here. I am getting the value is around, that is the R1 minus R2 by, it's a C, that gives your sine alpha. Now therefore from right angle triangle O1P, I will just take sine alpha becomes O1P by O1O2. Now we know that the O1P is nothing but R1 minus R2 and O1O2 is nothing but our C. So this is our sine alpha. And one more thing, and remember that this is our sine alpha is equal to R1 minus R2 by C, and we know that for a very small angle the sine alpha becomes alpha. Okay. Now I will just take here itself, for small angle sine alpha is nothing but alpha here. Now I will just remove this part here. Now sine alpha becomes alpha means therefore I can take this term as alpha is nothing but R1 minus R2 by C. Now this term I will just substitute here in this particular alpha. Okay, I can just substitute as R1 minus R2 by C. So I will get finally L0 is equal to this pi into R1 plus R2. So plus 2 is there. Now in place of alpha the value the equation is R1 minus R2 by C. Now again there is one more R1 minus R2 is there. Now if I multiply with this R1 minus R2 I will get the whole square, that is that square here. So this is 2C as it is, and the remaining term is R1 minus R2 whole square by C. Now we just see this two term here, it's a 2 times here and there is one time here, Okay, we just subtract this to here. So we'll get L0 is equal to, so now again I'll just write this 2c at the starting here. Now second thing is this is a pi plus R1 plus R2. Now out of these two, after subtracting here, I'll get the simple in a simple form as R1 minus R2 whole square by C. Now this is actually the length of the given belt for a open belt drive condition. I hope that you have understood this derivation, and it's a very simple and it's a very important for the examination point of view. Please, if you like this video, please comment, share with your friends and subscribe to our channel.